The James Webb Telescope has, as of late, sent an incredible message that has left all NASA researchers flabbergasted. The best optical telescope in space has been observing various components of our immense universe from a truly distant past interval, discovering other irregularities. Anyway, the new picture it has sent has made waves through the worlds of science and cosmology. What surprising picture has the James Webb Telescope spotted? Did it, at some point, capture an extraterrestrial rocket in the farthest reaches of space? Join us as we investigate the disturbing new images that the James Webb Telescope has revealed. Pictures we have never seen before. On the off chance that you're amped up about staying fully informed on news from the universe and its environmental components, join our channel. Also, don't forget to turn on notifications. NASA's $10 billion James Webb Space Telescope was launched from the French Guiana spaceport, a European spaceport. When it arrived at its new, amazing home, this infrared observatory provided stunning perspectives on the universe to investigators and stargazers. As the most prominent and most exceptional space observatory up until this point, examiners were excited to see the first scientific images captured by the telescope. What they saw almost left them frozen. When the James Webb rotated its tools toward the notable pillars of creation, it captured the well-known dust mists in perfect detail. These pillars are situated in the constellation Serpens, around 7,000 light-years from Earth. The pillars of creation are part of the Eagle Nebula, huge billows of gas and dust that were first imaged by the Hubble Space Telescope in 1995. Since then, the brilliant shine of the newly imaged pillar points has been discovered. The photo captured by the James Webb Space Telescope reveals the pillars of creation in much more critical detail. A few stars are visible that were not seen in the previous picture captured by Hubble, some of which formed just 2 or 3 million years ago. This was a huge scientific progression. The James Webb Space Telescope has also examined the so-called Pandora's cluster in a shocking image, named after Pandora of Greek folklore. The cluster is a region predicted by Albert Einstein in 1950. These new images surprise researchers as they reveal previously unknown details about the space around it. Anyway, it is important to note that this area of space has a formal name, SMACS 0723, which is part of the cluster called Pandora. This cluster is home to a variety of distinctive designs. What makes this picture so fascinating is that it's been seen before. However, only the central region was analyzed by the Hubble Space Telescope. This suggests that other astronomical mysteries still need to be uncovered in this captivating region of space, until the James Webb directed its powerful infrared instrument to observe it. The observing group used the telescope's near-infrared spectrograph and near-infrared camera as part of the Deep Perception program. Before the final epic pictures were taken, they were combined into an all-encompassing image. This revealed approximately 5,000 infrared sources in the Pandora cluster, which is about 3.5 billion light-years away. The picture captured by the James Webb Space Telescope accomplished a remarkable balance between depth and expansiveness, which could change our perspective on cosmic development. A feature of the image is a brilliant foreground star in the Milky Way, whose unique diffraction pattern was created by the James Webb. Also visible are brilliant sources of white light surrounded by a dim glow, corresponding to much more distant galaxies that are part of the Pandora cluster. Although human-made technology is crucial for observing this universe cluster, space experts also relied on a natural anomaly proposed by Albert Einstein in his theory of general relativity, published in 1915, also known as gravity. These revelations continue to captivate researchers and space experts. The James Webb Telescope has captured unconventional astronomical phenomena that even specialists cannot fully explain. One such mystery is the concentric rings found around a distant star, which still can't be fully understood by space experts. The image, shared on Twitter by a resident scientist, kicked off a flurry of comments and debates among the online community. The image showed a star called WR140, surrounded by normal, wave-like circles that gradually faded. What was striking was that the circles were not completely round, but had a fairly square appearance, sparking speculation about a potential extraterrestrial origin. Nevertheless, some experts argued that it was just nature performing something that seemed phenomenal when seen from a single point of view. Sometimes, natural phenomena can appear dynamic from certain perspectives, but have straightforward explanations. Still, questions remain. Why do they have that particular shape? Why are they so regular? These questions have puzzled specialists like Mark McCaffrian an interdisciplinary researcher with the Joint Working Group on Science and a science advisor to the European Space Agency. He called it amazing. In a Twitter thread, he explained that the sharp blue pattern is a relic of optical diffraction from the bright star WR140 in the picture. Regardless, he noted that the red twist actually exists and represents a series of shells around WR140 in space. Despite the fact that NASA is expected to provide an explanation soon, young stars generally tend to radiate bright blue. Over time, they take on a redder glow as they consume their fuel, something that keeps cosmologists cool-headed. Still, they didn't expect to see old red stars in the early universe, which is what the James Webb Space Telescope was designed to observe. Nor did they hope to see galaxies up to multiple times more massive than our Sun. These red spots in the images captured by the James Webb Space Telescope appear to be, by all accounts, more monstrous. According to Jan Kai, the most massive galaxy in our sample is estimated to have masses between 2 and 3 times less than that of the Milky Way. She added, "The discovery is shocking because galaxies as extensive as our own were found when the universe was only 3% as old as it is now." Leah also mentioned that before cosmologists begin changing cosmological theories to explain how these systems formed so rapidly after the Big Bang, they need to ensure that the striking red areas they are observing aren't something else. Otherwise, alternative explanations would also require groundbreaking ideas. For example, stars in the early universe could have produced light in unusual ways due to a lack of heavy elements not included in current models. The pictures that revealed these anomalies offer only a glimpse into the immense power and potential of the James Webb Space Telescope. Its ability to look deeper into space and further back in time than any other telescope has allowed scientists to witness formations and celestial behaviors that defy long-standing astronomical models. These red-hued galaxies, massive and ancient, challenge our understanding of the timeline of galaxy formation. If galaxies this large existed so early in the universe's history, then our current theories about the rate at which galaxies form and evolve might need significant revision. Beyond galaxies, the telescope has also offered unprecedented detail in observing nebulae, star clusters, and even exoplanets. For instance, its spectroscopy tools allow it to detect the atmospheric composition of planets orbiting other stars, identifying elements like water vapor, carbon dioxide, and methane, key ingredients in the search for life. Each image and data set the James Webb sends back is like a puzzle piece, slowly assembling a grander picture of the universe's origin, structure, and future. Its high-resolution infrared capabilities enable it to see through dense clouds of gas and dust, revealing the birth of stars and planetary systems, much like how an ultrasound allows us to see the development of life inside a womb. The implications go far beyond science. They touch on philosophy, our place in the cosmos, and the nature of life itself. Every new discovery stirs wonder, excitement, and even existential contemplation among researchers, thinkers, and everyday observers around the globe. Yet, as the telescope continues to peer into the unknown, it also reminds us how much we still don't know. For every question it answers, it seems to raise several more. Could there be life beyond Earth? What unknown forces shaped the early universe? Are we witnessing phenomena that science hasn't yet learned to describe? Only time, and the relentless gaze of the James Webb Space Telescope, will tell. Strange worlds were taken over by Webb's. Close to the infrared camera, as part of the large-scale science program for early release, the group intends to soon return to these systems and the SMACS 0723 cluster to gather the spectra of distant light sources. The spectra decompose the observed light by dividing it into frequencies, thus revealing the chemical and physical characteristics of its source in a remarkable way. Spectra provide very precise distances. Compared to these things, the distance and nature of each of these items is connected to the others. And if we know the distance, we can identify their characteristics. Leah states that just a few months after Webb's team got rid of the initial perceptions, researchers had to revise their findings and hypotheses about the early universe. Noticing the early universe for the first time led us to discover something so surprising that it presents issues for science as a whole. Because of its difficulties, the entire early galaxy development picture has to be reconsidered. Another astounding picture the James Webb Space Telescope captured demonstrates the phantom galaxy, which appears to be turning into a whirlpool before our eyes. This new image, based on deep space data, highlights the dust paths of the universe, NGC 628 or M74, also called the perfect spiral due to its balance. The Phantom Galaxy is fascinating from a scientific point of view due to the enormous black hole at its center, according to researchers. Despite the fact that the Phantom Galaxy has been imaged several times, including by space observatories like the Hubble Space Telescope and the Spitzer Space Telescope, Webb's pictures stand out because of the near-infrared light that uncovered immense dust. Combined with the power of its extraordinary 18-segment hexagonal mirror, the James Webb Space Telescope, hailed as one of the most ambitious endeavors in space exploration, continues to astonish researchers with its extraordinary skills and discoveries. Launched with a mission to uncover the most profound secrets of the universe, Webb has not disappointed. From spotting the many facets and subtleties of distant galaxies to uncovering previously hidden characteristics, Webb's contributions to space science are rewriting the textbooks of our understanding. One of the telescope's most amazing achievements is its capacity for peerless observation, more than any other instrument before it. By utilizing cutting-edge infrared technology and a massive 18-segment mirror, Webb has opened a new area of investigation, unlike its predecessor, the Hubble Space Telescope, which mostly functioned in the visible and ultraviolet ranges. Webb's capabilities allow it to penetrate large clouds of dust and observe hidden celestial objects. This ability has proven essential in its observations of the famous pillars of creation within the Eagle Nebula. Webb, in infrared, uncovered exceptional details of these large areas of gas and dust where new stars are born. The telescope's ability to see through the thick nebular material has allowed astronomers clearer insights into the processes of stellar development and birth. In particular, Webb's observations of galaxy clusters like SMACS 0723 and Pandora's cluster have provided fresh insights into the massive structure of the universe. By capturing thousands of infrared sources within these clusters, Webb has enabled space experts to study the growth and evolution of galaxies across cosmic time. The deep field images obtained by Webb not only expand our understanding of the dynamics of galaxy clusters, but also challenge existing cosmic models of structure and evolution. One of the most captivating revelations made by Webb is the presence of ancient galaxies that defy conventional theories of the universe. These galaxies, observed when the universe was just a fraction of its current age, have masses that rival or surpass that of the Milky Way. Such discoveries raise key questions about how galaxies formed and grew in the early universe. The James Webb Space Telescope, JWST, has rapidly become a focal point of space exploration. Advancing our understanding of the universe is one of its most amazing achievements. Its ability to capture light from the very first galaxies is based on Webb's cutting-edge infrared technology, which enables it to observe objects that are either too far away or too dim for other telescopes. Webb's observations have provided new insights into the formation and evolution of these ancient galaxies, offering a deeper understanding of the early universe. Recent images from Webb have shown galaxies in various stages of development and evolution. For example, Webb has captured intricate details of early galaxy mergers, where two or more galaxies collide and interact. These mergers are critical events that occur during a galaxy's life cycle, influencing their structure and star formation rates. The telescope's detailed observations of these processes are assisting researchers in assembling the history of galaxy evolution, offering a look at how galaxies like our Milky Way may have evolved over billions of years. In addition to its observations of distant galaxies, Webb has also focused on nearby celestial objects, such as star-forming regions within our own galaxy. The telescope's ability to see through thick interstellar dust has allowed astronomers to study the birth and development of stars in extraordinary detail. Webb has provided new views of regions like the Orion Nebula, one of the closest and most active star-forming regions to Earth. These observations are assisting researchers in comprehending the intricate processes involved in stellar birth and the development of planetary systems. Another significant area of research enabled by Webb is the study of exoplanets. The telescope's infrared capabilities are particularly well suited for analyzing the atmospheres of exoplanets, allowing researchers to detect and characterize them. Writing on Webb has already begun, examining the atmospheres of multiple exoplanets and providing data on their temperature, atmospheric composition, and even possible indicators of habitability. This information is crucial for locating planets that might support life and for understanding the conditions that may influence distant worlds. As researchers continue to analyze the data, Webb's role in exoplanet research is expected to grow significantly. By studying the light that passes through or reflects off an exoplanet's atmosphere, scientists can identify the presence of elements like water vapor, carbon dioxide, methane, and potentially even biosignatures, chemical markers that might suggest the existence of life. This capability marks a major step toward answering one of humanity's oldest questions. Are we alone in the universe? Moreover, Webb is not only focused on deep space, it's also revolutionizing our understanding of objects within our own solar system. The telescope has observed planets like Jupiter, Neptune, and Uranus in unprecedented detail, capturing their atmospheric conditions, ring structures, and thermal patterns. These observations are shedding new light on the dynamics and compositions of the gas giants and ice giants, offering insights that previous missions and telescopes couldn't provide. The James Webb Space Telescope has also turned its gaze towards smaller solar system bodies like asteroids, comets, and even the moons of planets. By studying these bodies in the infrared spectrum, Webb can detect signs of water, ice, organic molecules, and the thermal properties of their surfaces. This information is crucial for understanding the building blocks of our solar system and how it evolved. Webb's incredible sensitivity and resolution allow it to perform time-domain astronomy as well, tracking changes in brightness or position of celestial objects over time. This enables astronomers to monitor supernovae, variable stars, and other transient phenomena in real time, helping to unlock the physics behind stellar death and the formation of black holes and neutron stars. Its wide range of capabilities means that Webb is not limited to one field of study. It is a multipurpose instrument, advancing our understanding of astrophysics, planetary science, cosmology, and the origins of life. Each new image and data set it delivers brings us closer to answering some of the most profound questions about the universe. As the scientific community continues to process and interpret the treasure trove of data coming from Webb, collaborations across disciplines are forming. Astrophysicists, planetary scientists, chemists, and even biologists are working together to decode the signals coming from the edge of time and space. In just a short time since its launch, the James Webb Space Telescope has proven to be more than just a successor to Hubble. It is a leap forward, a transformational observatory reshaping how we see the cosmos. Its legacy will undoubtedly influence generations of research and spark the curiosity of future explorers for decades to come.